Thank you so much for joining us. This is a really exciting webinar. It's the first actually Weatherwise webinar that we've done so far this year. So looking forward to the discussion that's gonna happen. And this is of course all about offshore. And so we want to talk about weather risk and offshore because I think it's an obvious no-brainer of an issue. It's something that everyone who's working in offshore already knows. But what we want to talk about today is doing something more consistent, more data-driven, and trying to create a pipeline and a process that's going to help you in that. So just a couple of housekeeping. This will be recorded. It'll be sent to you guys as a file that you can watch, and then later on it will be published on YouTube. We are having Q&A at the end, but please do send your questions throughout the session. I will be the one kind of asking Niels and Marian questions, but also if you have any questions about the platform, then yeah, please direct them at me as well. Niels and Marian and I talked about this webinar quite a long time ago, and they will introduce themselves. They're from Prove, so that's a partner. So EHAB and Prove are working together to try to improve the use of technology within construction planning and construction risk. So that's what we're going to be focusing on today. And Weatherwise, if you don't know, is the kind of the end-to-end full life cycle platform that we've developed at EHAB. That's been in the market now for a number of years. We're on about 350 projects globally, but we are moving more and more into the offshore world. So that's what we kind of want to talk about today. And I think hopefully the slides are moving forward and you can see them all. But just let me know, and just in case not, Niels. But the reason that we're in this business is because weather risk is of course going up. All of the data is showing us that even out at sea, we're having more storms, higher wave heights on average, greater temperatures, of course, is driving that. And so there's this kind of clearly there's weather risk is spiking, but there's a gap between where our actions are and the solutions that we have today. So I think that's why we introduced Weatherwise into construction industries, because we thought we need to take a more consistent approach with this. So I'm just going to share a handful of stats with you, again, to kind of whet the appetite as to why we're here today and what we're going to be talking about. So the first is that, of course, the ocean is warming. So for every degree of warming that happens in the ocean, there is at least 1 meters per second increase in extreme wind speeds. And so, as you can imagine, if that just means there's more storms happening more frequently and those storms are more powerful, then that has a compounding effect on vessel uptime, productivity rates when you're doing maintenance, all of the different things that, of course, are going to drive efficiency in the offshore world. Also, that over 40% of offshore wind farms in Asia and Europe have actually been exposed to wind speeds that exceed the turbine design already. So this is something that we're seeing in lots of projects on land as well, where maybe a 1 in 100, 1 in 1,000 year design window is actually being exceeded. There's a really good case study of a Network Rail new project getting flooded on like almost the first day of its install, even when it was a new flood defense. So this is happening everywhere. 63% of coastal regions are seeing these extreme and increasing extreme wind speeds since 1940. So we're seeing a massive increase. And of course, in the zones where hurricanes are happening, well documented that the number of those higher category 4 and 5 hurricanes are increasing. But just last year or in 2024 as well, we saw in the UK and in the North Sea a massive number of named storms, which is obviously a huge place where a lot of offshore work is taking place. And so I don't think I need to tell you guys this. Average wind, extreme gusts are both increasing. So it's not just the extremes, but the average is moving northwards as well. And we're talking pretty significant costs for vessels. So, up to $500,000 per day, euros, pounds. Basically, that's the cost of operating some of these vessels. And of course, there's only a limited number of these vessels in operation as well. So you can imagine just the overall cost of downtime for contractors, for clients who are operating in the space is going to continue to move upwards, unfortunately. But I think some of the good news, I guess, is that with costs alone counting for about 30%, we're basically saying that weather is one of the highest value things that you can do to optimize for in the most expensive phase of your assets. So that's why we want to talk to you guys today, because I think if you can move the needle on weather risk, in the construction phase, then that's going to set the project up for success. So hopefully those facts land with you and kind of whet the appetite for why we're here today. So just a quick bit about the Weatherwise platform before I hand over to Niels and Marian. So as I mentioned, we've been operating on land and globally for quite a while now. What we do is we process schedule data, as Marian will show you in a bit, and we run some different types of analysis models comparing with weather and climate information across many different categories, and we do that with about a 92% accuracy. The data that we get access to is a kind of a global data set made up of about 48 years now of historic data, many different weather types. At sea, it's about a 30-kilometer grid. On land, it's about a 9-kilometer grid. This is made up of course, all of the weather stations, but also satellite data, buoy data, balloon data, and that all gets compiled into a big data set. And of course, we factor in climate change into all of that as well. And the way that we think about this is that every single activity is going to have different types of sensitivity to weather. So we don't just think in rain or in wind, we actually think in activity types. So maybe barges lifting maintenance might be 3 activity types. And of course, each of them might have different sensitivities to different things, snow or rainfall or wave heights or lightning strikes. And so therefore in the system and the way that we're going to talk about it today, you can configure this. And this is a really granular way of starting to map and understand your risks in a more detailed way. And we actually do this mapping using activity codes or UDF fields in your program, again, as we'll talk through in a little bit. We've kind of just released a load more data onto the system focused on offshore, which is again why we wanted to do this session. So you can see some of them there. There's 19 new variables, standard stuff. So we did have wave heights before, but now we have many different variables, ocean currents, directions, different types of swell heights, wave heights, sorry. So we're going to dive into this in a little bit more detail again later, but we really think this is something exciting because of the types of data that you can actually get access to now. And before I kind of wrap up and we move into the kind of the demo and talking more about how we can actually help. So some of the outputs that the platform is going to be able to deliver is create the creation of deterministic calendars. So we have an official integration with Asta Power Project. We also integrate with Oracle Primavera P6, and we also do actually integrate with Microsoft Project. And basically, we'll take your existing calendars and apply the weather calendars on top of that for barges, for maintenance, for whichever activity types that you've selected, and we'll do that automatically for you, which, creation of calendars can be quite a time-consuming process. So we make this happen really quickly using the tool. And the same can be done with probabilistic calendars. So we integrate into Delta Acumen Risk, into Nodes and Links, into Oracle Primavera Cloud. We also have an API into OPC. So we're gonna show that in a little bit. We also integrate into PRA and Safran Risk as well. So yeah, really excited to show you some of those things. And this is just a kind of high level who we integrate with. So maybe to finish, we've been around for a number of years. As I said, we work with a lot of different people, including partners like Prove. And so, my hope today is that we can give you a little bit of an insight into maybe the way that you might improve how you do your weather modeling on your projects. Yeah, without further ado, I want to introduce Niels and Marian. So these guys are gonna take over the show now. Yeah, Niels, over to you.
Thank you very much for the introduction, Josh. And it's my pleasure to be here and to see in the attendees so many familiar faces. And we don't see our faces, but familiar names. So welcome, everyone. What I want to do here is very quickly and briefly introduce to you who is Proof and what we do, the challenges we face in the offshore, and then I will hand over to Marian. So my name is Niels. I'm the lead of operations at Proof, and I'm bringing Marian with me. She's a master in probabilistic approach to project controls like no other. And she will take you through the process of achieving probabilistic schedules using EHAB Weatherwise, which are robust for weather as a consequence. And I'll just take in it a few minutes to introduce our company. So we are strong believers in data analysis as a key driver for project success. And we strive to deliver excellent project controls on prestigious projects, not just in offshore, but also in pharmaceuticals and in the infrastructure industry. We're on a mission to enhance the management of project data at an enterprise level and to boost awareness on data-driven project management. And we do that through 6 services of ours. So to complete these missions, we staff key roles on project controls teams like planning engineers, earned value management analysts, and we apply expert services like Monte Carlo risk analysis or 4D scheduling to all of these projects. We give management advice on a corporate level, select and implement the best-in-class software, and train our teams in every step of the way to become a more mature project organization when it comes to project controls. In terms of software selection, we embed software analysis and partnerships with the software providers as a core strategy within our operations. And it is that is what brings us here today. So we believe in having access to weather data and being able to perform probabilistic analysis on the project schedule using best-in-class tools like Weatherwise will help us on our mission to enable data-driven project management. It's not our first rodeo in the offshore industry. Proof has been involved in multiple offshore wind projects. We supported more than 40 offshore wind projects through planning and risk analysis in all the project phases, resulting in more than 35 gigawatts of installed wind farms, which is 10 to 15% of the EU target, or 15 to 20 nuclear reactors. Yearly, they produce 128 terawatt hours, which is equal to the consumption of Belgium and Denmark combined. This supplies 25 million households, or 12.5% of the EU households altogether. Furthermore, we support multiple offshore civil projects in the risk analysis of their operations. Let's take you through the steps to get to a project plan as we see in the industry today. First, we define the workable parameters thresholds for vessels, per activity type, and per location. Based on years of historical data, the weather department defines workable window thresholds. Using this, we define the workability per period on the year at a certain T or a P level. Then the scheduler manually defines the weather calendar into their scheduling tool for every combination of these parameters. So the probability, the vessel used, the activity type, the location where it's installing or loading. And for every activity, the planning engineer assigns the calendar and adjusts the calendars manually to show different weather scenarios and P schedules, easily resulting in a combination of over 20 deterministic calendars per project. They are usually never revised again during the production of these projects. And if any of these parameters change, the process repeats itself and the planner goes crazy. This process is mainly supported by our good old friend Excel, MATLAB, and a series of macros. But what if I tell you that we can do better? So let's dive into the Weatherwise demo. Marion, it's up to you.
Thank you, Niels. All right, let's dive into the demo because that's why you're all here. Let me just share my screen. So with all our experience at Proof, we thought we are capable. We can make our own wind farm. So we thought, okay, let's do that. Let's make our own wind farm. And that's also the case that I will be discussing today. So we're making our wind farm. I actually already made a nice schedule about our wind farm because we're very good at making schedule. You don't need a schedule to use AHAP, but I'm showing it here because I will use it later. So we have a schedule for a wind farm, and it includes foundation installation, cables, turbine installation, and this is a schedule that I want to use for my project. So we have a very nice schedule. We're very good at scheduling, but one thing that we don't have is we don't really have an idea of weather downtime. We also don't have any measuring tools. So we're looking like how can we know the weather downtime because that's needed for our schedule. We're going to use AHAP for that. Let me just go to AHAP. So this is where AHAP comes in place. So when I go to the site, this is my platform that I have. And this is the platform where I can have for all my different project sites, I can have my weather data. So it's nice that it's one platform that I can use for all my different project sites. Now, the first thing that I need for weather data is where is my project site? Because, my weather depends on the location. So let's say we want to do a project at the coast of Belgium. We can create a site here on the platform and selecting where we want. We can select it on the card, or we can even fill in the coordinates, exact coordinates. Done that for our case, and I've made a project site so that I can get my project data. So I've selected the coast of Belgium where I want our proof wind farm. And now that I've selected this, I want to see, okay, but what are the weather parameters for this? In order to get that information, you can go to report and you have a few options here. The first thing that I want to see is the historical weather. So here you can find the historical weather. You can see here all the different parameters that are available. The ones that are most interesting for offshore will be wind. So you have wind speeds at 10 meters, 100-meter wind gusts. And also, as Josh has shown before, you actually have quite a lot that's now also for marine that can be interesting. Like wave heights, wave period, but also the direction of your wave or your ocean current or ocean current direction, and even a lot more. So you can request historical data for the last year, 5 years, 10 years for a specific parameter. I have requested this for winds. I requested for the last 5 years my wind weather data, and then I can, EHAB will show me here what has been the wind for the last 5 years. So this is nice. I don't need another measuring tool in the ocean. I can directly ask EHAB what are my parameters for the past 5 years. And it also gives me a summary over a year in January. What are my P80 values? What are my P20 values? Voila. These are my weather data on my location. I can ask even more for ocean parameters. So what can I do with this? I can use this data to calculate my downtime. I can calculate this myself with a complex Excel, or I can ask EHAB Weatherwise to calculate it for me. However, in order for EHAB to calculate it, I first need to define what is a downtime. I have my parameters, but what is a downtime? So what is a downtime will depend on my type of activity. Do I have lifting activities or something else? But it will also depend on my equipment. So we will define these as categories, depending on my activity and my equipment. We will call it weather rules. So your weather rules you can also find here, and this is where we define those categories. So there's already quite a lot of standard categories available in EHAB, but you can make your own. You see here, for example, for asphalt, you see the weather downtime defined. However, let's make our own categories for our project. So I'm just gonna add a category. Let's say we have wind turbine installation, and it's by a certain vessel. Let's call him Filiberke. So this is our category. And we will define the threshold. So Filiberke can also only do the installations when the parameters are within certain limits of wind, within certain limits of wave height. And the moment one of those limits is exceeded, it will count as downtime. So these are the thresholds that I can define here. Let's take wind speed, for example. Our wind speed needs to be less than 10 kilometers per hour. Voilà. This is my first threshold. I can also add more, but let me show it how it's shown in the grid. So I just added it here. I can look for it. Filiberke. So this is my category. It's not yet loading, but I can show you all the different parameters that I can still fill in. Let's, for example, go to marine. I have wind here. I have here my wind that I added with a maximum value. I can even add for specific direction a certain limit. I can add more also for marine. I can add also the wave heights, the wave periods. I can define them for certain directions or for any directions. So I can add those parameters here, and this will define what is a downtime. All right, good. I have my categories. I can mostly in my project, I will have multiple categories depending on my equipment and the type operations. But to calculate my weather downtime, it will be depending on when exactly my activities are happening. So for that, I will need a plan. For plan, I go to Plan Impact Summary. I have my site, I have my weather rules that I just defined, and next I can import my plan. So my plan that I import can be from an Excel file from P6, or it can be an MS Project file, or an Asta file. So I have my file from my P6, remember this project, which I can upload. And once I have that uploaded, so we can upload it here. Once I have it uploaded, I will just go to state this one. I have it uploaded here. The next step will be to assign my categories to my activities. So you can do this manually by going to the schedule and assigning each category to the activity, or you can already define this in your schedule by using a code. I've done this before, so I've added a code in my schedule, and I say I want to use this code to assign my categories. So for example, for the foundation, I actually defined a category for my foundations with a limit on wind and wave height. And then also for cables, I have defined another category. So I'm looking at it at a more high level right now. So these are my categories that I assign. I can also do that for my Filiberke, for wind turbine installation, and I can apply my changes. So this is how I apply my categories to my schedule. And then at the bottom, I will see per category which activities are applied. So my cable installations, and then on the foundation, I have my foundation installation. And then I have here my wind turbines also assigned. All right, good. I have my categories. The next step will be to simulate. So what he will do when you simulate, he will essentially do a Monte Carlo analysis. So he will use the historical data that is on your site, compare it with the weather rule, with your weather rules that you implemented, and do a Monte Carlo analysis. The thing is, when you would only look at your historical data and only use that one to estimate the weather downtime, you will not be able to take into account the current weather patterns that are going on, because we see with global warming, weather patterns are changing. We're going to more extreme weather patterns. And this is also something very nice of EHAB, is that they include that in their model. So they use their data that is available, and then they use the thresholds and they create a probabilistic model, also taking into account the current weather parameters and how they are evolving. And with that information, they build a probabilistic model, and then they will do a Monte Carlo simulation. So they will have a lot of iterations once you click on Run Simulation. So let's do that. Let's run a simulation. I actually have done it before. So when I run a simulation before, and then he will give me the results of that simulation. So what is the result of my simulation? EHAB will give me the total weather downtime in my schedule. So I have in total 17 additional weather days. However, only 10 of that is impacting my finish milestone, because in the planning, not everything comes after each other. I have some parallel activities. Of the total 17 additional weather days, only 10 is impacting my finish date. And this is looking at a P80 scenario, so a pessimistic scenario. In case you want other scenarios, for example, more pessimistic, if you want to look at a P90, this is also available. You can even look at other percentiles depending on how you are working in the department. So you have your different percentiles, and you can also request your weather downtime per activity and per milestone that is in your schedule. Let's do that here. So I can check for the different activities what is my P80 days and how many weather days are added to those activities. So this is another advantage, is that you can really check the weather downtime for each of these activities, but also look at a certain intermediate milestone, like, okay, what is the weather impact on that milestone? So you don't just have one value of P80, you can really go into detail for each activity and milestone. And then another thing, you can see the results. If you go to the bottom, you see what the main driver is for this weather downtime. So I see here that the wave height was the main parameter that caused my weather delay. All right, nice. I have my weather downtime. It actually went quite fast. I have on my milestone 10 additional days for a P80 scenario. However, I just heard that Filiberg is not available, so I will need another vessel. Instead of going through the whole process again, I can simply go to my weather rules. I can define either a new category or change my existing category, or I can add a new one with a new vessel, change my parameters that are applicable on my new vessel, reassign it, and simulate it again, and I have a new result. So easily, when I have a certain scenario, I can easily just change it here and directly get a result. Even, for example, so this is an example when my weather rules change, but it can also happen that, for example, my schedule will delay the start will delay with 4 months. What I can simply do is I can import a new schedule with a delayed start. I keep my weather rules and I do the analysis again and I look at my results. So very easy going back and forth to look at certain scenarios and see what my weather downtime is. All right, I have my weather downtime, but I want to do something with it. I would like to integrate it in my schedule. There's a few options here. Let me start with the first one. Let's say I want to add those P80 dates. I want to visualize them actually in my schedule, which is in P6. So under here in your integrations, you have a few options. I'm looking currently for my deterministic values. So I go to schedule integrations and I can select which tool I want. So I want it in my P6. And then I have the options to create a new project with my weather downtime calendar added to that project and also assigned to my activities. I can click on preview calendars, but I have that one here. So if I click on preview calendars to see which calendars will be generated, I can see them here. So he will create 2 calendars for cables and for foundations, and they will look like this. So these are the calendars that he will import in my P6. What can I also do? I can also ask to add a certain UDF fields, which immediately adds also my weather downtime on an activity level. Once I click on the bottom, he will create an XML file that I can import directly in my P6. And that will look something like, you just have to open the file first, and that will look something like this, where I have a P80 weather days column added, and you see also there is a new calendar added that is assigned on the activities based on what I added in EHAB. So this is in P6 directly what I can do to get from EHAB, from Weatherwise towards my schedule in P6. If you're working in OPC, there is actually a direct integration. So with an API, you can directly connect with your OPC environment, and you can click on generate calendar exceptions, and he will immediately automatically add those calendars in your OPC environment assigned to your activities. Voila. Now, this is weather downtime. There's a few other things that can go wrong on my project. So I have weather downtime, but it can also happen that I, for example, have a machine breakdown, or there is something wrong with my cable, and I need to fix it. So, and even more. So normally I would have a list with risks in my risk register that I can do risk analysis with it, for example, with Safran risk or with OPC. And I would like to add the risk of weather also in my risk analysis tool. I don't want that as a fixed weather downtime. No, I want to see what is my P80, my P20, what are all the good and bad scenarios of my weather. So for that, I would want to have an integration with a risk integration. So I can also go to risk analysis, and then I can choose, for example, Safran. And in Safran, I can ask to generate my risk calendar. I've done this before, so I can immediately show you what it looks like. So once you click on the magic button, you will get calendars that you can import in your Safran. So this is what my Safran looks like. This is my risk analysis tool, and I have two calendars that I could import from eHub. And this is a summary of it. But I can also show you during the iterations, he will have weather downtime days in my calendar. I can add this as a project, as a risk, and then I have a long list of risks that I normally have, plus I have my risks of my calendar that I can add to my simulation. And then with this information, I can do my risk analysis. So this way, I have it directly in my Safran. There's also, if you don't use Safran for your risk analysis, you also can do it in OPC, and that you can also use the integration for. So with the integration to OPC, you can directly click on Export Probabilistic Risk. If you click on Export Probabilistic Risk, you will generate automatically a risk. I show you here my OPC. So I have also my different risks. And you see here, by clicking on that button, there is a very long ID, but I generated 2 additional risks, and these are weather risks. These weather risks are created with the API, and you can use it also for your risk analysis in OPC. So you can also see per simulation the different weather downtime that he has added. Okay? So it's very nice to see that I have a tool and that I can directly integrate it in my schedule, that I can very easily add it as calendars, that I also can have a column with my P80 weather downtime. And it goes pretty fast. If something would change, if my start day would delay, or if I have a different vessel, I just go to eHub, I change my weather rules, and I generate it again, and you immediately see what the impact is in my weather downtime. So that is for the API. What is also with the API, if my project is ongoing, it's very nice that I can also, during my project lifecycle, I can actually also update my weather downtime. I can send back to eHub with my project that is ongoing, see what is the new weather downtime, instead of fixating on the calculated weather downtime from 5 years ago before the actual project. So for us, the main advantages of using eHub, first of all, you have one centralized platform. So you have one platform where you have all of your project sites, so all of your location, and you have all your weather data available on that platform. Which makes it also very transparent because you can immediately see what the historical weather data of each of these sites are. Then it's also in that model, when it's simulating, it creates a model which also takes into account the weather patterns evolution that is currently going on. So it also includes like what is happening with global warming. So that's also a very nice addition of eHub, that they're also incorporating that instead of only looking at what has been happening for the last 60 years. And also, instead of having one value, like one P80 value at the end of my schedule, I can really look into each activity, each milestone, even if they're not on the critical path, seeing, okay, what is actually the impact on those activities and milestones. Additionally, if I'm having different scenarios, I can really go to these different scenarios very fast, calculate the weather downtime in order to compare them with them. So the process is much more efficient than what we have seen before. Also, it's very nice that it's directly integrated in my planning, so which makes it easy to update my weather downtime based on how my plan is actually going, which helps also during my project life cycle to have an accurate prediction of the weather downtime. So these are the main things that we see a big advantage of using EHAB, because right now we see there's a lot of focus on calculating exactly the correct weather downtime so that it's correct on the hour. However, we're missing a lot the link with the schedule, and there, yeah, we're really missing all that effort that is put in calculating the weather time side, and then it gets lost in how it's actually implemented in the schedule. So that is where we see a big improvement for our weather downtime in the calculations. Voila, this was EHAB, how it works. I hope it was a little bit clear, but I think the main point is to have a plan of action. Niels, you can take over
Well,
from
yeah, the
here.
idea is that if you want to see EHAB in action on your projects, please feel free to reach out to us and to Josh. Like that, we can really test out if it suits your need. In any case, we do have the feeling that that EHAB triggers a lot of acceleration in the currently rather tedious process. So hence why we are very happy to partner with EHAB and present today. Thank you very much, Marion, for your demo. Josh, do we open the floor to some of the Q&A? I think I've seen you comment already on a lot of the questions.
Yeah, first of all, Marion, thank you so much for that demo. That was really helpful. And it's obviously sparked a lot of questions in the chat. And I have been trying to give an initial answer. But maybe I'll read them out to you, Niels, Marion, and we can kind of tackle them together a little bit as well. And there's quite a few. And if I have left a comment already, please respond to that comment, because there's a couple of clarifying questions that I've asked to folks. And we've got a good amount of time to do the Q&A. So yeah, really appreciate all the questions, folks, and keep adding them in. So the first one, I'll just go from the person who asked first. So someone is saying, basically, given a sequence of activities, each with their own set of limits, how do you approach combining those into a workability percentage? For example, a vessel's chosen heading affects the angle of incident between the incoming wave combined with the wave's period. They give a wave height limit that should not be exceeded. In other words, depending on the angle of the incident and period, the limit will be different. There is no single limit that can be assessed in isolation, but rather a combination of parameters that define workability. So how do you approach combining such linked activities limits into workability percentages for use in scheduling and calendars? Complex question. Marion, Niels, off the top of your head, do you have a response here? Because I did leave a response, but I wonder if you...
So if I understand correctly, you would have, first of all, different activities with different weather rules. And maybe in one of those activities, you would have a weather rule where you say, for example, if the wind wave comes from one direction, then the limit is, for example, 2 meters, while if it comes from another direction, it's maybe lower or higher. I was looking into the tool, so you can add directions where you say, okay, from that direction, that is my limit. However, I'm not sure if you can add multiple directions where you can define for each direction the limits within one weather rule.
Yeah, and so exactly, Marion, that's how I kind of answered the question to this person. The good news is, and as I said at the beginning, we're obviously new to offshore. This is a feature that we'd definitely be keen to implement, because it feels like if it is that level of sensitivity, the way you want to change the wave parameters, then we'd definitely look to do that. So yeah, today, as you said, Marion, it can't be done, but tomorrow maybe it can.
Maybe that's a good general remark. So when we talked to EHAB 2 years before, there has been a very big difference in what is added and what they have also, and also what they have in the back that they're going to implement. And also, I think, Joyce, for you, the question is, we really want to talk work with an offshore client to talk these things through and see how we can implement it the best that you can. So that's also a little bit of the setup, I think, of this webinar to really get that action going.
No, absolutely. And I think we can go into more detail with question askers afterwards as well. So if we haven't quite answered your question correctly, or if it is actually more of a longer discussion, then please let us know. So I'm just in conscious of time because I can see more questions coming in. So we've got another question here, which is about the historic data. Whether there is a API and also where the historic data comes from. So I'll just take this one. So as I say in the comment there, all of the data comes from the ECMWF Euro 5 model, which is a global gridded model, which at sea gives us a 30-kilometer granularity. On the coast, we can get 9 or 8-kilometer granularity. Those models are being refined all the time. We have an API for OPC, as Marion showed. We're developing APIs for other bits of software as well. And we also do have like a general API where you can pull data from the system. So talk to us about that. But I know the question asker then goes on to specify, can you change the historical data? So in the system as it stands, not in the front end. We of course can, if you have specific requests, we can change that. And if it is a feature that is consistently required for projects, then that's also possible. We're working on a feature which allows you to basically add data that you have into the system as well. So if you have a local weather station or if you have local buoy data, for example, we can use that to improve the accuracy of the model and the data in the system as well. That is all slightly more custom than something you just drag and drop it into the platform. The objective would be to make it drag and droppable and relatively simple, but it's that's a feature that's in the roadmap. So for you question asker in that sense, yes and maybe I think is the answer. But let's definitely have a conversation. So we've got another comment here. Do you need to remake the calendars when the start date of the project changes? Niels, I saw you.
I don't think so. So the tool generates based on the thresholds that you have entered, generates the probabilistic calendar, also taking into account the certainty level that you want to have. That's for the deterministic calendar, and it takes the entire project duration plus a little margin. So if the start date is not delayed by a year or two, then I think you can use the same calendars, right, Josh?
Exactly. Yeah. So I think we add a 12-month buffer. And as you say, the only reason you would update the calendar is if because we update our data set every month. So if let's say there was a 12-month delay, you would want to generate new calendars anyway. And also there would then be a whole year of additional data that would inform the climate trends in that new set of calendars. The only other time you might change the calendars is if there have been some many more new activity types added or thresholds have been changed, and therefore we need to recalculate those thresholds for those calendars. So hopefully that answers the question. We got another question here. So is the application able to manage operations that cannot be interrupted? Is it possible to account for the lost time due to abandonment recovery in case of severe weather? Is it possible to account for storm riding, i.e. partial abandonment recovery up to a given weather parameter and full abandonment recovery beyond that limit? Niels, Marion, I know this is one of the bits of feedback that you gave us, and I know we're still looking into doing this. So effectively, it's like a weather window feature where, if you have a 3-day activity, if the threshold is at all broken, you have to start that whole activity again. So that is not a feature that we currently have. But the second part of the question asker's question around basically full or partial abandonment, the way, and Marion kind of described this in the demo where she changed the thresholds and reran the simulation. So you could do a similar activity if you had multiple versions of the thresholds in your schedule. You could then export multiple calendars, and then, or for example, if you're doing it at OPC, you can compare multiple different model runs using the probabilistic modeling. So there's a number of ways that you could do that. It wouldn't be in one model run, though. It would be multiple model runs and then comparing the results of those different model runs to kind of determine that information. Quick one, can the lay route be taken into account? You can have multiple locations per project. At the moment, the 30-kilometer granularity at sea obviously is quite broad. We're looking at how to make that more granular. Availability of data is obviously the key there. We've got another question, and this one maybe, Marion, is potentially if you could share your screen again. So the question asker says, can you show how the work, non-work hours are distributed per day, week, month? I believe we could potentially just look at the calendars, the preview of the calendars again, potentially. I know I asked the question.
Wait, I'm looking. Yes, I will just share my screen. So I just opened the calendar, how it looks in P6. So this is the calendar that is generated from EHAB that is then imported. And this, I think that was also one of the comments, because the working, non-working is per day in the calendar. So what he will do is he will actually get the P80 simulation. Normally, correct me if I'm saying this wrong, Josh, but he will take the P80 simulation from EHAB and he will transform this in a calendar. So this is then how it looks. So it just takes random days based on that simulation, and it's either day or non-day, or working or non-working. So I think maybe one of the comments that could be is that they're looking more for like within a day, that there's certain hours and that are either non-working or working, or even just up to half an hour that is either working or non-working. But currently the granularity of those calendars is on a day level. So that is how it looks in P6.
Maybe another comment. So you said we randomly assign them. We actually assign the days based on the most likely down days for each day. Of course, it might appear random, but that's because it's combining multiple different weather types. And then we do actually, we have a new tool at the moment, which is a kind of a data studio product, which can look at 15-minute granularity. That currently does not output a construction calendar though. But it does provide lots and lots of data and the ability to kind of combine and manipulate that data. So for the question asker, talking about kind of, let's call it intraday assessments, we can do that. It's just, a slightly different way of doing it. The same question asker says, when you add weather risk as a risk in the Monte Carlo analysis, does it apply the same weather condition on all locations for that moment? And as I say, not currently. We don't have that kind of like persistence of events because it is just purely a probabilistic model. It's not actually modeling the weather. It's modeling the likelihood of those rules being broken. But again, Niels, Marion, this was a comment that you guys made again. So it's something on our list of quite tricky problems to solve.
Also, in your defense, Josh, there is currently not a single tool that solves this particular issue. If we're scanning them on the market, it's about the correlation of the non-working events between different probabilistic calendars. That's really something that we've not seen any tool do in the past. It's a gap in the market offering, Josh. Jump to implement and have the holy grail.
If it was that easy. No, I appreciate that. My data scientist, or the head of data at EHAB, Paolo, has been looking at it for a little while and having a think. So we'll keep your eyes peeled on that one. We have another question here that was just asked, and I think as you say, Niels, the second part of the question wasn't fully pasted. But the first part of the question is, how many categories can you assign to one task? So I think the simple way to answer this is each activity type, so let's just say a barge A, can only have one category assigned to it. However, that category in Weatherwise, in EHAB, can have multiple weather types. So there is no way to have multiple categories per task, because then there would effectively be conflicting rules for calculating the probabilities. So we face the same challenge in onshore work, where someone might have like a formwork and concrete activity combined together into one, even though formwork and concrete will have very separate rules that determine if they are going to be impacted by weather or not. What we would basically say to those people is if they want to, they should separate those activities out so that then you can assign different categories. Or again, depending on the approach that you want to take, you can either just use the most sensitive or the least sensitive rules as the kind of the standard for that category. And of course, then you have to understand how that's working in your schedule. But I don't know if question asker, you can elaborate on the second part of that question. We've got a couple of minutes left. So does anyone else have any questions or wants to jump in with anything?
How do we do that? You mean by chat or by speaking up?
Either way, if anyone wants to ask a question out loud, please raise your hand. We can you just use the little raise hand icon if you would like to.
I'm not sure if they're not. I see hands.
Let's unmute you then. Okay, go for it. Hopefully you're unmuted.
Can you hear me?
Yes.
Yes.
Okay. Just a question out of interest on the calendars. You've shown the view in Primavera, which shows calendar per day. Just wondering if we show a schedule with activities of hours or half hours or whatever, smaller than a day, and you have a calendar with, let's say, 2 or 3 days after each other of non-working, like you've shown, that gives a very bad view on your schedule. I understand that with your analysis, your end date might be correct, but I mean, that would show an activity to be 4 days, of which 3 days is downtime. That doesn't really I mean, it's difficult to sell if you understand what I mean.
Yes, I think because that's how weather works. You can have 3 good days and 3 bad days. I think to get a complete picture, it's always nice if you have a risk analysis. But if you're looking towards an average, I think you would want to have it percentage-wise per day that you say, okay,
Yeah,
on
exactly.
average. Yeah.
Yeah,
No, I
I
get that
understand
question.
indeed. If you have bad weather, it's usually more than half an hour or an hour, but just as a view or in average, it doesn't really show nicely to say that a lift of a pile takes 5 days, for example.
Yeah.
I guess the comment I would make on that is that there are multiple different ways of exporting data from the system. The deterministic calendars currently function on days, just purely because when we suggested to some of our clients of doing them intraday, basically people said, no, please don't do that. So I think this is when we're coming from onshore to offshore, there's definitely some, let's just call them translation problems that have to occur in terms of the kind of granularity. What we have looked at in the past is effectively shortening the number of working hours in a given day as the calendar, and therefore you would give, which would effectively have the result of having less working hours in a day. And so that is a feature that we've looked at implementing. So maybe Charlotte, we can talk about that another time, but it may well be that is an appropriate way of displaying it from a deterministic calendar perspective.
Yeah. Okay, thanks.
We have 1 minute left. Perhaps Niels and Marion, do you have a final comment or a final question?
We do have the second part of the question in the chat that was missing before.
Okay, so for the Monte Carlo simulation in the system, how many iterations is this done? So in the Weatherwise model, the plan impact summary report that Marion showed, the kind of walkthrough, that's 1,000 simulations. If you were to take calendars or probabilistic risk events from EHAB into Safran or OPC or whatever, then I believe you could select however many model runs that you want to do. I don't know what it goes up to, but you could do 10,000, I suppose. Correct me if I'm wrong, Marion or Niels, but
I didn't see that option when I tried. When I imported in Safran, he did 100 samples. But if you do more, and for example, in the tool, you can select more simulations, but he will use it based on 100 samples.
Well, thank you, everyone. It's the end of the session. We will send the recording to you. If you do have any further questions, put them in the chat, but I think we don't have time today now to ask them. Of course, yeah, I'll send you all an email and we can continue the conversation either with Niels, Marion, or myself. But Yeah, Niels, Marion, thank you so much for joining, and thanks everyone for taking the time. We really appreciate it. All right.
Thank you.
Have a good rest of your
Thank
day.
you, everyone.
Bye bye. See you
Bye.
later.
Bye. Talk soon. Ciao, ciao.